Okay, so a quick look at composite functions. So the idea of a composite function is when one function can't describe perfectly what's happened. So my understanding of Hooke's law is about extending a spring. And if you start to stretch a spring, like hang a weight off a spring, so you've got a little spring, and if you attach a weight to it, the spring, or weight, maybe not very artistically sound these drawings, but hopefully they do the job. It's my weight. Then what will happen, of course, is the spring will start to stretch. And as you increase the amount of mass, the stretch in the spring will become more and more and more. And what happens is initially you get this nice straight line. And that works for a little while, but then after a while, as you add more weight to it, what actually happens is that you then get a different sort of function later on. The stretch doesn't continue in a straight line, it stretches now as a curve. And we call that a composite function. It's got this function from here to here, which is a straight line. Then it's got this function from here to here, which is a curve. It'll be made up of two functions. Now, some composite functions don't always join up perfectly. So you might get functions where everything is static, stationary, stationary, stationary. It's getting to this point, and then it's jumping up, and suddenly it's going from here, and now it's going in some sort of funky fashion, like this perhaps. Now, I don't know if you noticed what I did here, but with the composite function, I've gone up to this point, I've put a round circle here. This means that this rule down here applies up to, but not including this point of x equals 0. At the start of this one, I've got a solid dot. This is the value at x equals 0. So the round dot means don't include that point. The solid dot means include that point. So they're what composite functions look like on a graph. Composite functions, which is what the graphs look like. Algebraically, what has to happen with a composite function is it has to be defined. So if we say function of x, we have to say more than one thing is happening here. So for instance, in my first graph that I drew, which you can just actually see through the page here, it might have been something like x plus 1, and that would be for x that was, say, less than or equal to 3. So 1, 2, 3, x plus 1, then it stopped. And then it might have been something like, I'm trying to think of what would have been an appropriate graph here. So maybe x minus 3 all squared plus 3. So something like that perhaps, actually plus 4 would probably be a better one, plus 4. And that would have been then bringing this curve shape here, x minus 3 all squared plus 4 would have been bringing the curve shape. And so the function needs these two definitions, this one for x greater than 3. So this is probably what you're going to be presented with in a question. You're going to be given a composite function, and you're going to be asked to find some sort of function values. So for instance, you might be asked, for example, find the value of f of 2 plus f of 3 plus function of 5. And so what we need to do then is we need to substitute 3 times in, and we just need to pick which of these two rules is the appropriate rule to substitute in. So function of 2, we look at this value in here, and we look at these, what we're told here. X less than or equal to 3, well that's 2. 2 is less than or equal to 3. I'll sub into this rule here. So for function of 2, it's x plus 1, or in other words, 2 plus 1. Function of 3, well 3 is in both of them, but this one up here is including the 3. It's saying x is less than or equal to 3. So it's including the 3 in this rule. So once again, put the 3 where the x is. That one becomes 3 plus 1. Function of 5. Well, 5 is definitely bigger than 3. So I'm going to have to sub in this rule. So wherever there's a x, I'm going to put 5 in. So 5 in for x gives me 5 minus 3, then square it, add 4. So here's my 3, and here's my 3 lots of calculations for each one, having chosen the correct rule to substitute in. So 2 plus 1, that's 3, plus 3 plus 1 is 4, plus 5 minus 3 is 2, squared is 4, plus 4 is 8. So at this point here, it's just adding and subtracting, in this case, answer 15. So the composite function will be set up like this, and basically it's trying to model that graph that I showed you before. This rule holds for up to values up to and including 3. This rule is a rule for any values bigger than 3.